Geometry lesson 8-2. We've been dealing with proportions and how we can solve those proportions. So we're going to look at a few problems and some other scenarios involving properties of proportions. Now, it says here that if A over B is equal to C over D, then A over C is equal to B over D. And if you actually look at what's taking place here, the B and the C have swapped places. So it's sometimes easier to look at in terms of numbers. I like to use very easy fractions. Let's use 1 over 2 is equal to 4 over 8. So there is clearly a true fraction taking proportion here. 1/2 is the same as 4 over 8. Now, according to this property, I can swap the 4 and the 2, and I would get 1 over 4 is the same as 2 over 8. And that is true. 2/8 is the same as 1/4. So that proves that the property works. So if you have a fraction, these are interchangeable, right? As with the 1 and the 8, they would also be interchangeable. If you put 8 over 2, you're going to get 4 over 1. 8 over 2 is the same as 4 over 1. Another property, a little bit harder to see what's taking place here, is it says A over B is equal to C over D. So again, we have a fraction that's equal to another fraction. And you'll notice there's the A over B, but it's like they added the denominator to the top. And here's the C over D, but they added the denominator to the top. So let's again use our examples that are pretty easy. We know 1 over 2 is equal to 4 over 8. If we use this concept, the denominator here is 2. So we would end up with 1 plus 2 over 2 is equal to 4 plus 8 over 8. Now that might not be easy to see, so let's simplify it. 1 plus 2 is 3. That makes 3 over 2. And 4 plus 8 is 12. You can always tell if two numbers are equal if you multiply the means and extremes. 3 times 8, 24. 12 times 2, 24. Also, 4 goes into this 3 times and 4 goes into this 2 times, so that makes the fraction 3 over 2. So again, this proves that both of these properties work involving fractions. Here's a situation where we have a shape, and we know that this is true. The distance from M to Q over M to N, this relationship, this fraction, is the same as LQ over LP, that fraction. We need to find the distance from L to Q. In other words, we need to know what is this. One of the biggest mistakes is that people use this 6 and 15. But you have to look at the actual values here. We know we have a proportion, so I like to draw a line equals line. And if you look, it says M to Q. 15 is not M to Q. N to Q is 15. So we need to look at this whole distance, which is 21. So 21 is M to Q. Then I got to look at M to N. M to N is 6. Now let's look at how this is made. It's saying the whole distance over the short base is equal to the whole distance LQ over the short base. So it's really the same parts that we're dealing with. Now we're trying to find LQ. We don't know what it is. That's the unknown. Since it's an unknown, I'm going to give it a variable. But I know that LP is 5. So you can now use cross products. And you could say 6 times x has to equal 21 times 5. So 6x equals 21 times 5. 6x equals 105. Divide both sides by 6. And we can find our answer for the entire distance from L to Q. 6's cancel. 6 goes into 10 once with 4 left over. It's next to 45. It's almost 48, which means 6 would go in exactly, but it's going to go in 7 times, which is 42. 3 left over is a half. So x is equal, this distance right here is not 17 and a half. The distance from L to Q is 17 and a half. So if we were actually asked to find the distance from P to Q, you'd have to subtract that 5 away. You've got to be very careful. One of the biggest mistakes is people think that this value is 17 and a half, and it's not. All right, geometric mean of two positive numbers A and B is a positive x such that you can put the positive A over positive x equals x over b. So if you had cross products, you would go a times b and x times x, which makes x squared equals a times b. And if you want to get x alone, you would do the square root, and you would end up with x is equal to the square root of a over b. So that's where it comes from. This is the geometric mean. So let's try it out. Find the geometric mean of 35 and 175. So we will say x equals the square root of 35 times 175. So you must do the multiplication first. So when you multiply 35 times 175, you get 6,125. And then the geometric mean is the square root of that. So we have the square root of 6,125 gives us 78.3. So the geometric mean is 78.3. Last problem. You're building a scale model of a boat. It's 62 feet long and 23 feet wide. The model will be 14 inches long. How wide should it be? So here's the model of the boat that's 23 feet by 62. That's the actual dimensions. It's a very big boat. And then we have another one. We're trying to make the model. It's going to be 14 by what? So if you set up your proportion, now if you wanted to be very, very careful, you could actually convert the 62 feet. You could say 62 times 12 inches is 744. And you could say 23 inches, or 23 feet times the 12 inches is 276. So then you're at least dealing with inches and inches. Now when I set up proportions, I like corresponding parts. So a part on the big that matches up with a part on the small. Another corresponding part on the big that matches up with a corresponding small part as well. And if you set it up like that, you'll be okay. So we have a part on the big that's 744. And the corresponding part on the small for 744 is 14. We have a part on the big that's 276. But we don't know the part on the small. It's unknown. And then we're set up to use our means and our extremes. So we end up with 744x is equal to 276 times 14. So I multiply 276 times 14, and I get 3864. And all I have to do is divide by 744, and I'll have x in inches. So 3864 divided by 744, and we get 5.19. So just over 5 inches is going to be my value for this unknown part of my model. Now if you think about it, 5 times 3 is going to be a little bit more than 14. 276 times 3 is 828. A little bit more than that. 23 times 3 is 69. A little bit more than 62. Alright, so it still works out. But when you've set it up, a part on the big that matches up with a part on the small, and a corresponding big to a corresponding small, you'll set up your proportion and you'll be okay.